They're calling it the biggest hint of alien life ever found. A planet 120 light-years away, and a 99.7% confidence signal that something unusual is happening in its atmosphere. The James Webb Space Telescope has just picked up molecules we've never seen on any other world. Molecules that, on Earth, are produced almost entirely by life. Not machinery, not volcanoes, not storms, life. In the last few days, the scientific world has gone from cautious curiosity to stunned disbelief. Is this the moment we've been waiting for? Did JWST just stumble upon the first real evidence that we are not alone? Or is the universe playing its most fascinating trick yet? Because hidden in the light of a distant red dwarf star, wrapped in the thick atmosphere of a strange Hycean world, lies a signal so perplexing, even the experts can't decide if it's biological or something we've never imagined. Stay with me, because in the next few minutes, we're diving into the discovery that could change everything we know about life in the universe, or expose one of the greatest scientific false alarms ever recorded. Welcome back to the channel where we explore the mysteries of our universe, one mind-bending discovery at a time. And today, we're diving into one of the biggest scientific shocks of the decade: a distant planet, a strange chemical fingerprint, and a telescope powerful enough to challenge everything we thought we knew about life beyond Earth. If stories about alien worlds, deep space secrets, and cosmic breakthroughs fascinate you as much as they fascinate me, you're in the right place. Drop your thoughts in the comments as we go. I love reading your theories, and feel free to share this video with someone who enjoys having their mind blown. Alright, let's get into it. Why this discovery matters. For decades, humanity has searched the skies with one question in mind: are we alone? We've scanned radio signals, mapped thousands of exoplanets, and studied atmospheres light years away, yet every time we got close to an answer, the universe stayed silent. That's because detecting life is incredibly hard. We can't fly to distant planets. We can't scoop their oceans or sample their soil. Instead, scientists look for biosignatures, chemicals that, on Earth, are linked to living organisms. But even then, the signals are usually faint, uncertain, or explained by natural processes that have nothing to do with biology. That's why true biosignature detections are rare, and why this new observation has sent shockwaves through the scientific community. K2-18b, a planet discovered back in 2015, has always been interesting. It's a sub-Neptune, larger than Earth, possibly covered in a global ocean beneath a hydrogen-rich atmosphere. But for years, it was just one world among thousands. Then JWST took a closer look, and suddenly K2-18b was everywhere. Headlines, newsrooms, research discussions, scientific panels. Because JWST didn't just detect the usual atmospheric gases, it picked up hints of molecules that, on Earth, come almost exclusively from biological activity. And that's when everything changed. This isn't just another exoplanet. This isn't another maybe or possibly. This is the closest humanity has ever come to detecting a chemical fingerprint that could be linked to life beyond Earth. And the closer we look, the stranger it gets. Meet K2-18b. K2-18b lives about 124 light-years away, orbiting a dim red dwarf star. It completes one full orbit every 33 days, a tight, fast path compared to Earth's 365-day journey, yet thanks to the low luminosity of its host star, the amount of stellar energy it receives is roughly comparable to what Earth gets from the Sun. In terms of size and mass, K2-18b is dramatically different from Earth. Its radius is about 2.6 times that of Earth, and its mass is roughly 8.6 times Earth's. Its overall density is lower than Earth's, indicating it's not a dense, rocky planet. Instead, scientists believe it has a substantial gaseous, hydrogen-rich envelope, and perhaps a deep liquid ocean beneath. Because of these characteristics, substantial water potential plus hydrogen atmosphere plus temperate energy input K2-18b is considered a leading example of a theoretical class called Hycean worlds. Hycean worlds are broadly envisioned as planets with vast global oceans and hydrogen-rich atmospheres. On paper, they offer conditions that might support life very different from the familiar rocky Earth paradigm: liquid water, sufficient warmth, and atmospheric chemistry that could host or sustain biology. Imagine K2-18b as a moody, alien aqua world. Under a scarlet-red sky cast by its red dwarf sun, a planet twice more than twice Earth's width, drifts slowly. Maybe beneath a thick, hazy hydrogen atmosphere lies a global ocean, hundreds of kilometers deep, stretching endlessly, without continents. Light from the star filters through layers of mist and cloud. Waves, if waves exist, crash silently on shores we can't see. The silence is deeper and older than on Earth. Yet despite some Earth-like aspects, water, energy from a star, potential warmth, the differences are profound. The crushing pressure of a deep ocean, the thick, hydrogen-laced atmosphere, the chance that the surface, if there is a surface at all, might be far from stable or Earth-like. Gravity is stronger, chemistry is stranger. Time might flow differently. In short, K2-18b isn't Earth 2.0. It's a world of extremes, eerie, vast, alien. It challenges everything we use to define habitable. But that's exactly why scientists find it so enthralling. If life exists there, it might be unlike anything we know. What JWST found when James Webb Space Telescope turned its gaze to K2-18b, it did more than just snap a pretty picture. It used a technique called transmission spectroscopy, watching K2-18b pass in front of its star and analyzing the starlight that filters through the planet's atmosphere. As this light crosses the atmospheric layers, certain wavelengths are absorbed by the gases present. By looking at which wavelengths are missing, the telltale fingerprints of absorption, scientists can infer what molecules exist in that alien sky. What did Webb see? The initial observations already showed clear signs of methane and carbon dioxide, two carbon-bearing molecules that, on Earth, often play a role in biological and geological cycles. But more recently, using a different instrument on Webb probing the mid-infrared region, researchers detected something far more intriguing: spectral features consistent with either dimethyl sulfide DMS or its close relative dimethyl disulfide DMDS compounds on Earth, almost exclusively produced by living organisms, especially marine microbes like plankton. On Earth, DMS is not a background gas released by volcanoes or rocks. It's generated life from tiny algae and microbes in the oceans. Its presence in Earth's atmosphere is fleeting because sunlight and chemical reactions quickly break it down. That makes it a compelling biosignature. If you see DMS, it usually means life is or was recently active. Imagine the moment the data arrived. Astronomers plotted the spectrum from K2-18b's transit and saw absorption dips exactly where DMS-DMDS should absorb IR light. The signal held up under independent analysis with a separate instrument in a different wavelength range, reducing the chance of instrument-specific glitches. The realization spread quickly. This wasn't just another exoplanet with generic gases. This might be the first chemical fingerprint of life beyond Earth. But even the scientists behind the discovery admit it's not simple. The interpretation is tricky. While DMS and DMDS produce those absorption features, so might other unknown molecules or even non-biological chemistry under alien conditions. Even more, drawing a straight line from DMS detected to life exists assumes alien biology resembles Earth's in its chemical byproducts. No guarantee of that. The data offers a tantalizing hint, a strong candidate for a biosignature, but not proof. In short, JWST didn't just glimpse a distant planet. It captured the whispers of a potential ecosystem, a signature that, on Earth, is inseparable from living oceans. Whether those whispers belong to life on K2-18b or to unknown atmospheric tricks remains the greatest cosmic cliffhanger of our time. 99.7% confidence. When headlines blasted the phrase 99.7% chance of life, they were referring to something very different from what it sounds like. Scientists didn't calculate a 99.7% probability that alien life exists on K2-18b. What they measured was the strength of the signal, the likelihood that the spectral fingerprint JWST detected isn't just random noise in the data. In statistics, this kind of measurement is called a 3 sigma detection. Imagine flipping a coin. If it's fair, you expect half heads and half tails. But if you flip it 1,000 times and get 600 heads, you'd start thinking something strange is happening. Now imagine you flip it 1,000,000 times and the pattern holds. That's closer to what sigma refers to, how unlikely a result would be if nothing unusual were really happening. A 3 sigma result means that if the atmosphere of K2-18b had none of these intriguing molecules, the odds of getting a false signal this strong from sheer randomness would be about 0.3%. In other words, the data is unlikely to be a mistake, but that doesn't tell us what the signal truly represents. The universe loves to surprise us with chemistry we don't yet understand. In astrophysics and particle physics, the bar for declaring a discovery is higher, much higher. The problem begins when scientific language meets public headlines. Media outlets often treat sigma levels as if they directly translate to probability of life, because 99.7% chance of a biosignature signal sounds almost the same as 99.7% chance of alien life. It's not. One measures statistical confidence in an atmospheric feature, the other makes a claim about biology, something far more complex, uncertain, and difficult to prove remotely. Scientists are careful for a reason. A molecule can be misidentified. An unknown atmospheric process could mimic a biological signature. Instrument calibration might distort faint signals. Or, in the most humbling possibility, alien planets may produce molecules through chemical pathways that don't exist on Earth, meaning our assumptions could be wrong. So the real meaning of the 99.7% confidence claim isn't that we've found life, it's that JWST has detected something in the atmosphere of K2-18b that almost certainly isn't random, something real, consistent, and strong enough to take seriously, and in the search for life beyond Earth, that alone is monumental. Why scientists aren't celebrating yet? Even with the tantalizing detection of potential biosignatures on K2-18b, scientists are careful to temper the excitement. The first reason is that unknown chemistry scenarios could mimic the signals of life. While dimethyl sulfide and its relative molecules are strongly associated with biology on Earth, there is no guarantee that alien planets follow the same rules. Exotic atmospheric reactions, unusual photochemistry under a red dwarf star, or previously unobserved geochemical processes could produce similar signals. Another concern is the possibility of instrument artifacts. The James Webb Space Telescope is the most powerful observatory humanity has ever built, but even it is not immune to calibration errors, sensor noise, or systematic uncertainties. Multiple instruments and independent observations are required to confirm that the signal truly originates from the planet's atmosphere and not from a glitch in the data. The planetary structure itself adds complications. K2-18b is a sub-Neptune, far larger than Earth, with a thick hydrogen-rich atmosphere and potentially extreme pressure at its ocean layers. These conditions make interpreting atmospheric chemistry far more complex. Signals that seem biological to us may be entirely consistent with high-pressure, high-temperature chemistry that has no counterpart on Earth. Scientists emphasize that we cannot simply assume the same rules of life or chemistry apply. Even the researchers themselves express cautious wonder. One senior astrophysicist described the detection as incredibly exciting, the strongest hint yet of life outside our solar system, but we must not get ahead of ourselves. Another added that, until we see the same molecules with more precision in different wavelengths and rule out non-biological sources, this remains a compelling mystery, not a confirmation. These caveats do not diminish the significance of the signal. They highlight the delicate balance in science between discovery and certainty. K2-18b has opened a door to one of the most profound questions in human history. Are we alone? But as the data shows, that door swings both ways, offering hope and mystery in equal measure. The thrill lies not in certainty, but in the pursuit and in the anticipation of what future observations might reveal. The better than Earth claim. Some headlines have gone further than science, dubbing K2-18b a planet better than Earth. The reasoning comes from several factors. Unlike many rocky exoplanets that sit too close or too far from their stars, K2-18b orbits in the temperate zone of its red dwarf host. Its atmosphere appears relatively stable, and models suggest it could harbor a global ocean beneath the thick hydrogen layer. For scientists looking for life, these conditions make K2-18b a compelling candidate. A stable source of energy, abundant water, and a protective atmosphere are all prerequisites for life as we understand it, and on paper, K2-18b ticks these boxes. Yet the reality is likely far more extreme than Earth. The planet's hydrogen-rich envelope creates an atmosphere that is vastly denser and heavier than ours. Surface or ocean pressures could be crushing, tens or even hundreds of times greater than what humans or terrestrial animals can tolerate. The red dwarf star provides much less visible light than the Sun, meaning the planet is bathed in dim, reddish illumination, which would drastically shape any potential photosynthesis-based life. The temperatures and chemistry in such an environment may be hostile for complex multicellular organisms, and high-energy stellar flares common to red dwarfs could periodically bombard the planet with radiation. The type of life that might exist on K2-18b, if any, would almost certainly be microbial or plankton-like. Tiny organisms thriving in an ocean beneath layers of hydrogen and methane, similar in scale to Earth's oceanic plankton, but adapted to alien chemistry. We are not talking about forests, animals, or intelligent civilizations. Life would be simpler, but potentially abundant and resilient, clinging to survival in ways we are only beginning to imagine. This contrast highlights a key challenge. Human expectations of habitability are inherently Earth-centric. We imagine planets better than Earth in terms of comfort, gravity, breathable air, or familiar ecosystems. K2-18b may be better for microbial life in ways we barely comprehend, but for humans or complex organisms, it is a harsh, alien world. The lesson is clear. When it comes to exoplanets, what counts as habitable, or even better, depends entirely on the lens through which we evaluate life. If life exists, what could it be like? If life exists on K2-18b, it would almost certainly be radically different from anything on Earth. Beneath its thick hydrogen-rich atmosphere, the planet may host a vast global ocean, perhaps hundreds of kilometers deep. In such an environment, life could exist as microbial communities floating freely in the water, forming ecosystems similar to Earth's plankton but adapted to alien chemistry. These organisms might survive on chemical gradients, extracting energy from interactions between water, minerals, and atmospheric compounds rather than sunlight. Unlike Earth, where photosynthesis dominates life's energy cycles, K2-18b orbits a dim red dwarf star that emits mostly infrared light. Any light-dependent organisms would need to harvest energy from wavelengths much weaker than the Sun's visible light, possibly developing entirely novel pigments or biochemical pathways. Some scientists speculate that life could rely on chemosynthesis, using chemicals like methane or hydrogen sulfide for energy processes found in Earth's deep-sea hydrothermal vent ecosystems, but taken to extreme scales under K2-18b's pressure and chemical conditions. The ocean itself could create layers of distinct ecosystems. Near the upper reaches, microbes might interact with traces of starlight, drifting in a hazy twilight. Far below, under crushing pressures, life could exist entirely in darkness, sustained by chemical reactions and the movement of fluids through the ocean floor. These organisms might form vast colonies, glowing faintly with bioluminescence to communicate or attract partners, producing chemical signatures that eventually rise into the atmosphere, the very molecules JWST may have detected. Imagine it as an alien, watery world of quiet motion and chemical symphonies. Life could be abundant, resilient, and persistent, yet invisible to the naked eye, existing in forms that challenge every assumption about what life looks like. For scientists, the detection of potential biosignatures on K2-18b is not just data, it is a tantalizing window into what might be a truly alien biosphere, operating under rules we can barely imagine, yet potentially echoing the same principles that made life thrive on Earth. Why this discovery hits different. Throughout human history, we have looked up at the stars and asked the same question: are we alone? The detection of potential biosignatures on K2-18b touches something deep within that age-old curiosity. It is more than a scientific puzzle, it is a mirror reflecting our desire to understand our place in the cosmos. For centuries, life beyond Earth has been the domain of speculation, philosophy, and imagination. Now, with the James Webb Space Telescope, we are approaching a moment where that speculation can be tested. People crave confirmation of life beyond our planet because it challenges the very core of human identity. If microbial ecosystems exist on K2-18b, it would suggest that life is not a unique accident, but a natural outcome of chemistry and physics, a pattern woven into the fabric of the universe. That realization changes how we view ourselves, transforming Earth from a solitary oasis into one of many potentially living worlds. The psychological impact is profound. Knowing that life might exist elsewhere can inspire awe, humility, and hope. It encourages us to see the universe not as a cold, empty void, but as a place capable of nurturing living systems. It reminds us that the search for life is not just a scientific endeavor, but a human journey, a story of curiosity, persistence, and wonder that stretches across generations. Ultimately, the discovery on K2-18b hits differently because it touches the universal longing to connect with the unknown. It whispers the possibility that we are part of a much larger, vibrant cosmos, and that somewhere in the quiet oceans of a distant world, life may be quietly thriving, waiting for us to find it. Are we looking at alien life? The evidence from K2-18b is compelling, but far from conclusive. James Webb's observations have revealed molecules like dimethyl sulfide that, on Earth, are almost exclusively produced by living organisms. The spectral signal is strong, with a 3 sigma confidence level, suggesting that what scientists are seeing is real and not a statistical fluke. Yet, it remains a hint, not proof. Unknown chemistry, extreme planetary conditions, and the limitations of our instruments leave room for alternative explanations. Scientists themselves are cautious. They describe this detection as the strongest hint yet of life beyond Earth, emphasizing that extraordinary claims require extraordinary evidence. Confirmation will require additional observations, independent verification, and careful analysis to rule out non-biological sources. Even with these caveats, the discovery is historic. K2-18b has become the most promising candidate in the search for extraterrestrial life, a distant world whispering possibilities about biology beyond our planet. While we cannot yet say life exists there, the tantalizing signals have opened a new chapter in humanity's quest to answer one of the oldest questions in history. Are we alone? If this discovery has you wondering what else might be out there, drop your thoughts in the comments. Do you think we're truly alone in the universe? Or could life be thriving on distant worlds like K2-18b right now? I want to hear your theories, no matter how wild or cautious. Make sure to hit subscribe and turn on notifications, because in our next video we'll explore another mind-bending exoplanet discovery that could reshape how we think about life in the cosmos. For now, remember this: the universe might be whispering secrets across the light years. The real question is, are we listening?